G'day folks, it's Clinton Moss here with Gunner Energy Services, and we're continuing on in our series Pulling Back the Curtain, where I'm going to introduce in these short clips fundamental knowledge around well control, well intervention, and complex completion. It's Saturday afternoon, I was so bored, I didn't know what I was going to do, and I said, I know, I'll make a ranging video. I know it's weird, right? But I love this stuff. Okay. So first of all, let me set the stage for you. Why do we need, before we talk about ranging, let's talk about some of the challenges we have in just drilling a wellbore. Okay, when we drill a wellbore, we take a measured depth and an inclination and an azimuth at a particular position, and then we have a collection of these measurements. And essentially what you do to create a downhole position is we integrate through that path to get a northing eastings TVD downhole. Now there are errors associated with every one of those measurements, so they're compounding errors, so you'll have some uncertainty. Now, in the event of a relief well, let's say, for example, which I've illustrated over here, we can't just aim at the target and drill based upon our normal surveying procedure because the errors are such that we would not hit the target well. So what do we need? We need something relative downhole that doesn't suffer from compounding errors, and that's where ranging comes in. Okay, so where's the word or the term ranging come from? Think about an Olympic athlete who is practicing with her firearm shooting a target, okay, on a firing range. Or think about a range finder. For example, if you wanted to count wildlife, you could, with a range finder, look and see how far away they are and determine how many that there are, okay? So that's kind of where the term came from. Now, in a downhole context, what we're talking about is determining a distance and direction from some downhole point in space, i.e., let's say a relief well, to some other point in space, the target well, okay? It's a vector quantity, so we have a distance and a certain bearing, a distance and direction. So that is ranging in a nutshell. Now, we have different types of ranging. Predominantly over the last 30, 40 years, really magnetic ranging has been the primary technique, okay? So we detect magnetic fields and we determine a distance and direction in that fashion. Now we also have acoustic ranging that's new on the scene in the last, let's say, 5 years. And in this case, the physical phenomenon that is used to determine the distance and direction is a reflection of sound waves. So actually we listen for these sound wave reflections, and that's how we determine the distance and direction. Okay, so folks, in the next episode, I'm going to talk about active versus passive ranging. Okay, what do I mean? Probably a lot of you have heard that. And we'll talk about access versus non-access techniques. So that is to say, if we can access the target or offset wellbore, or we cannot. Let's say in the event of a fire, okay, or some other issue on the rig. Now, we'll be going through that, and I'll introduce certain patents and certain tools, and we'll look at actual case studies and go through all the different types of ranging tools. And then what we're doing is building our way up. So all you folks can ascertain what tool is proper or what tool is the most rightfully deployed in a certain situation. So folks, it's Clinton Moss with Gunner Energy. Stay engaged, keep commenting. I really love reading your feedback. And if you have a good case study, please suggest it and I'll include it. Thank you very much.